Okay, in this video we're going to look at our third installment of how to solve word problems. And this video is specifically going to deal with consecutive integer problems. So let's first start out by talking about what a consecutive integer is, and then we'll look at some sample problems. So consecutive integers basically are integers that differ by 1. So for example here, we have 3, 4. So 3, then 4, that differs by 1. 6, then 7, then you have negative 22 and negative 21. Those are all integers that differ by 1. Then we also have something called consecutive odd integers and consecutive even integers. So those are going to be integers that differ by 2. So you have 1 and 3. You have negative 7 and negative 5. Those would be examples of consecutive odd integers, right? They differ by 2. And then consecutive even integers, for some examples here, we have 6 and 8 here. And then we have negative 12 and negative 10. So now that we understand what consecutive integers are, and then consecutive even and odd integers are, we're going to go through and look at some word problems that deal with this. So here's a simple one to start. Two consecutive integers sum to 39. What are they? So two consecutive integers, how do we set that up? Well, if the first or the smaller integer, let's say we said that was x. We know that consecutive integers are going to differ by 1. So again, if this is the smaller, the larger one is going to be 1 more than that. So I can say plus x plus 1. Okay, so if this number is the smaller, then the next one would be that number plus 1. So that's how I get x plus 1 here. So this would be the larger one. And again, I know the sum of both of these numbers is 39. So that's a real simple equation to set up. So if I solve this, x plus x, I'll just rewrite this real quick. X plus 1 equals 39. That's going to be 2x plus 1 equals 39. Subtract 1 from both sides of the equation. And I'm going to get 2x equals 38. Oops, and I wrote 28 for some reason. All right, so to solve this, we just divide both sides of the equation by 2. And we'll get x equals 19. Now, are we done? Well, no, we just know that x equals 19. That doesn't really solve our problem for us. We have to go back up here and remember that we said x was the smaller number. So if x is the smaller number, the larger number, which is x plus 1, is going to be 20. So those are our two consecutive integers that sum to 39, 19 and 20. And if you add those two together, 20 plus 19, you do get 39. All right, let's move on and look at another problem. Two consecutive odd integers, sum to negative 8. What are they? So we can set this one up just like we did the last one. If we let the smaller one be x, and this is the smaller number, we let that number be x. Since these are consecutive odd integers, the larger one will be x, that smaller number, plus 2. So plus x plus 2. This is the larger. And then this sums to negative 8. Okay, sums to negative 8. So again, we've set up our equations, pretty simple. We just want to solve it now. We're going to get 2x plus 2 equals negative 8. And I'm going to subtract 2 from both sides of the equation. And I'm going to end up with 2x equals negative 10. Divide both sides of the equation by 2. And we're going to get x equals negative 5. And again, we're not done. We know that x was representing the smaller of the two consecutive odd integers. So the smaller one will be negative 5. Don't let yourself get confused because you're working with negatives here. Remember, it'd be negative 5 plus 2, which is going to give you negative 3. Okay, so there are your two consecutive odd integers. And if you add those two together, negative 5 plus negative 3, you do get negative 8. Let's look at another one. Okay, find two consecutive even integers where the smaller okay, where the smaller added to 5 times the larger, gives a sum of 298. Okay? So this one's a little bit more difficult because of the wording. So again, we want to find two consecutive even integers where the smaller added to 5 times the larger gives a sum of 298. So again, let's let the smaller one be represented with x. It's going to be smaller. And the larger one, since we're dealing with consecutive even integers, they differ by 2, will be x plus 2. Now to set up our equation, we really need to read back through this. Find two consecutive even integers where the smaller, which is x, added to, so the smaller, which is x, is added to 5 times the larger. So 5 times the larger is 5 times this quantity here, x plus 2. And we have the smaller being added to that, so x is being added to this. And it gives a sum of 298. So again, we want two consecutive even integers where the smaller, again that's x, added to 5 times, so 5 times the larger, this is the larger, is going to give you a sum of 298. Okay, so we have our equation set up. All right, so let's solve this. We have x plus, I'll just go ahead and do distributive property here. 5 times x is 5x, plus 5 times 2, that's 10, equals 298. And so x plus 5x is 6x, plus 10 equals 298. We subtract 10 from both sides of the equation. We get 6x equals 288. Then we're going to divide both sides of the equation by 6. So you're going to get x equals 48. Okay, but again, we're not done. We need to go back up here and make sense of it. 48 is the smaller. So then the larger would be 50. So we put 48, comma, 50. And then we're going to check to make sure that this works out. So there are two consecutive even integers where the smaller, so 48, added to 5 times the larger, so 5 times 50 is 250, is 298. And yes, this is a true statement. If we add these two together, 48 and 250, we get 298. So we have the correct answer here. Our consecutive even integers are 48 and 50.